More than half of everything that exists is already lost to you, not destroyed, not hidden, simply unreachable. Right now, as you sit on a small planet orbiting an ordinary star, the universe is expanding so quickly that light from vast regions of reality will never arrive here. No telescope, no future technology, no patient civilization will ever see them. Those places exist. They just no longer belong to your sky. This is not a dramatic ending. There is no explosion, no collapse, no warning. The universe does not tear itself apart. It grows quietly, steadily, and in doing so, it leaves you behind. When people talk about the universe, they often imagine a complete picture waiting to be discovered, as if all of reality is out there, patiently shining, simply requiring better instruments and more time. But this assumption is already wrong. The universe you can observe is not the universe as a whole. It is only the part that managed to send light before distance became final. Think about that word, final. Not far, not difficult, final. There are galaxies whose light began its journey toward Earth billions of years ago and will never finish the trip. Space itself is stretching faster than that light can travel. Each second, the gap widens. The signal falls behind. Eventually, it gives up, not in any physical sense, but in a deeper one. The universe no longer allows the message to arrive. From your perspective, those galaxies simply fade away. They do not explode. They do not announce their departure. They cross an invisible boundary and are gone from history as far as you are concerned. This is what makes the idea unsettling. The universe is not just vast, it is selectively accessible. You live inside a bubble of visibility, a region defined not by walls or edges, but by time. Light travels at a finite speed, and the universe has a finite age. That combination alone already limits what you can see, but expansion tightens the constraint even further. It turns distance into exclusion. The night sky feels complete because it is quiet, because it does not show you what is missing. When you look up, you see stars scattered across darkness, galaxies arranged in delicate patterns, faint smudges that represent systems larger than imagination. It feels generous. It feels infinite, but it is not. The sky you see is a curated remnant, a shrinking archive of what once could reach you. The most uncomfortable part is not how much has been lost. It is how easily you accept the illusion of completeness. Your senses evolved to handle nearby things. Your intuition was shaped by walking distances, by horizons measured in kilometers, not billions of light years. The universe exploits this weakness. It presents a calm surface while quietly removing most of its contents from your reach. Nothing in daily experience prepares you for a reality where absence does not look like emptiness, and loss leaves no trace. There is no scar in the sky marking where unreachable regions begin, no color change, no boundary line. The universe does not distinguish between what you can know and what you cannot. That distinction exists only for you. If you could freeze the expansion of space and wait long enough, light from distant regions would eventually arrive. But you cannot freeze space. Expansion is not motion through space, it is space itself changing. Every second, the fabric between galaxies stretches, adding distance where none existed before. This means the universe is not merely large, it is actively editing what can be part of your experience. Imagine standing on a shoreline where the ocean is retreating faster than you can walk, not because the water is flowing away, but because the ground beneath it is stretching. Islands that were once visible slip below the horizon, not sinking, not destroyed, simply removed from the geometry that connects you to them. The universe behaves the same way. At some point in the past, many of the galaxies you can no longer see were visible to earlier observers, at least in principle. Their light could have arrived. There was a time when the cosmic conversation was still open. That window has closed. You arrived late. This is not a failure of science. It is not a mistake in measurement. It is the natural outcome of physical laws playing out over time. Expansion does not care about curiosity. It does not slow down to preserve knowledge. It does not value completeness. And yet, this realization changes how you should think about the universe. The question is no longer simply, how big is the universe? A better question is, how much of it was ever available to us at all? What you call reality is already filtered, not by culture, not by language, not even by technology, but by the structure of space-time itself. There are things that existed, things that still exist, and things that will always exist without ever becoming part of your story. You can build larger telescopes. You can send probes deeper into space. You can extend the reach of observation by centuries. None of that changes the fundamental limit. Some regions are not just distant, they are causally disconnected. They cannot affect you. You cannot affect them. The universe does not owe you access. This is difficult to accept because science has trained you to expect progress. Each generation sees farther than the last. Each tool reveals new layers. It feels natural to assume that this trend continues indefinitely. But here, progress runs into a wall, not a technological one, but a physical one. No future breakthrough will restore what expansion has taken away. The universe is not hiding its secrets behind complexity. It is removing them through geometry. And still, the night sky remains beautiful. This is the quiet cruelty of cosmic scale. Loss without drama, absence without grief. A universe that does not announce what it has erased. What remains visible becomes precious not because it is rare in absolute terms, but because it is all that can ever be known. Every galaxy you see is a survivor, a system whose light managed to outrun expansion long enough to reach you. Everything else exists beyond the reach of confirmation, beyond memory, beyond record. The universe that surrounds you is already incomplete, and it always has been. The phrase observable universe sounds reassuring. It suggests completeness, as if reality has simply drawn a neat circle around you and said, "This is what exists." But the comfort comes from language, not from physics. Observable does not mean total. It never did. What you can observe is only what managed to reach you in time, not what exists now, not what exists everywhere. Only what slipped through a narrowing window before distance became permanent. The observable universe is not a map of reality. It is a receipt proof of what arrived before the door began to close. This distinction matters because it changes the meaning of everything you think you know about scale. When astronomers say the observable universe is about 93 billion light-years across, it feels enormous, bigger than imagination, bigger than any human concept of space. But even that staggering number hides a deeper truth. That vast sphere is not the universe. It is a sample, a partial record, a fragment shaped by time and motion. The word observable quietly shifts responsibility. It makes the limit feel like yours, as if the universe is fully present, and your instruments simply haven't caught up yet. As if better telescopes will eventually fill in the missing pieces. They will not. Observation is not constrained by patience alone. It is constrained by causality. Light must travel. Space must allow that travel. And space is not passive. It stretches. It intervenes. It decides what can ever be connected. Every image you see through a telescope is a survivor of this process. Every distant galaxy earned its place in your sky by sending its light early enough, fast enough, through a universe that was still willing to carry the message. Most did not. The observable universe feels like a boundary in space, but it is actually a boundary in time. It marks how far light could travel since the beginning, under changing conditions, As those conditions evolve, the boundary does not stay fixed. It moves inward, excluding more and more of what exists. This is why the observable universe can grow in size while becoming less representative of reality. That sounds like a contradiction, but it is not. As time passes, light from more distant regions finally arrives, adding new galaxies to the observable record. At the same time, expansion accelerates, pushing even more regions beyond any future contact. The archive expands, while access shrinks. You are not approaching completeness. You are falling behind. The lie is subtle because it aligns with human intuition. In everyday life, seeing is a reliable proxy for existence. If something exists and nothing blocks your view, you expect to see it eventually. Distance delays perception, but does not deny it. The universe violates that expectation. There are regions where light is emitted right now that will never reach you, not because it is weak, not because something blocks it, but because the space between you and the source is growing too quickly. The universe is not hiding these places. It is stretching the road faster than any signal can travel. From your point of view, these regions might as well not exist. They leave no imprint on your instruments. They cast no shadow. They influence no measurement you can perform. And yet, they are as real as anything you will ever see. The observable universe does not separate the real from the unreal. It separates the connected from the disconnected. This has an uncomfortable implication. Science depends on evidence. Evidence depends on interaction. If something cannot interact with you, it cannot become part of your science, not because it is imaginary, but because the universe forbids the exchange. This is not a temporary limitation. It is not waiting for innovation. It is a structural feature of space-time. When cosmologists talk about regions beyond the observable universe, they are not speculating in the way fiction does. They are extrapolating from the same laws that explain what you already see. The same expansion that carries galaxies apart here continues elsewhere. There is no reason to believe reality politely stops at your horizon. In fact, the opposite assumption would be stranger, that the universe exists only where it can be observed. The observable universe, then, is not a container of existence. It is a shrinking island of contact, and islands create a powerful illusion. When you stand on one, the ocean feels empty beyond the shore, not because nothing is there, but because nothing can reach you from there. The boundary is perceptual, not ontological. This illusion affects how you interpret cosmic images. Deep field photographs feel like ultimate revelations, thousands of galaxies packed into a tiny patch of sky, each one a testament to abundance. But even these images are censored by physics. They show you what survived the race against expansion, not what truly fills the cosmos. For every galaxy in those images, there may be many more that never had a chance to be recorded. The observable universe flatters you by framing reality around your position. It implies that what matters is what can be seen from here. But the universe does not share that preference. It has no central vantage point. Every location has its own observable bubble, its own curated view, its own exclusions from another galaxy, far away. The contents of the observable universe would look different. Some things you can see would already be gone. Other things, invisible to you, would dominate their sky. Reality has no universal edition. This realization strips away a quiet assumption that knowledge naturally tends toward wholeness. In the universe, knowledge tends toward partiality. The longer time passes, the more fractured the cosmic picture becomes. The observable universe is not a promise of eventual completeness. It is a reminder of missed connections. Calling it the universe is convenient. Calling it observable is accurate. But confusing the two creates a comforting fiction that what you see is what there is. It is not. What you call the universe is already missing most of itself, and the missing parts do not announce their absence. They leave no gaps, no outlines, no sense of loss. The sky looks whole because it does not show you what it excludes. This is the quiet deception built into observation itself. You mistake visibility for existence and absence for nothingness. The universe does not correct you. It simply continues, far beyond what you will ever be allowed to confirm. When you look into space, you are not seeing distance. You are seeing time. This is easy to say and strangely difficult to feel. On Earth, distance and time are separate ideas. You walk farther. You arrive later. You wait longer. Nothing necessarily moves. Space trains you to keep these concepts apart. The universe does not. Light travels at a finite speed, fast by human standards, unimaginably fast, but still limited. And because of that limit, every photon that reaches your eyes carries a timestamp. It tells you not just where something is, but when it was. The sunlight warming your face left the sun about 8 minutes ago. If the sun vanished right now, you would not know immediately. For 8 minutes, everything would look normal. The sky would remain blue. The warmth would linger. Reality would already have changed. But your experience would not. That delay is small enough to ignore. Cosmic delays are not. When you look at the moon, you see it as it was just over a second ago. When you look at Jupiter, you see it nearly an hour in the past. The nearest star beyond the sun, Proxima Centauri, appears as it was more than 4 years ago. If something dramatic happened there today, it would already be old news by the time you learned about it. This is not a poetic metaphor. It is the basic operating system of the universe. Every step outward is a step backward in time. Every increase in distance is an increase in memory. By the time you look at nearby galaxies, the delays are measured in millions of years. Their stars are not where you see them now. Their shapes have already changed. Their internal histories have moved on. You are reading a chapter long after it was written. At the largest scales, this effect becomes overwhelming. The most distant galaxies visible to you appear as they were when the universe was young, before stars matured, before galaxies settled into familiar shapes. You are not seeing ancient objects preserved in place. You are seeing early drafts of reality. This creates a quiet but profound illusion. The universe appears layered in distance, but it is layered in time. Near objects feel present. Far objects feel remote, but none of them are synchronized with you. There is no single cosmic now that unites what you see. The sky is a collage of different eras. This matters because it undermines a deeply human assumption that observation reveals the present state of the world. In the universe, observation reveals the past. Always, you never see anything as it is. You only see it as it was, filtered by how long its light took to reach you. The farther you look, the older the information becomes. Eventually, you are no longer observing objects at all, but epochs. The universe turns distance into memory storage. This would already complicate your understanding of reality, even in a static cosmos. But the universe is not static. It is expanding, and expansion stretches light as it travels, increasing its wavelength, draining its energy, reddening its color. This process, known as redshift, is not merely a Doppler effect. It is a record of the universe's growth imprinted directly onto the signal. Light does not just tell you when something existed. It tells you how the universe changed while the message was in transit. Every photon carries 2 stories, one about its source and one about the space it crossed. By the time light reaches you from the edge of the observable universe, it has been traveling for more than 13 billion years. During that journey, the universe expanded dramatically. Distances multiplied, structures formed, conditions shifted. The light arrives exhausted, stretched thin, carrying information from a time when reality barely resembled what you know. This is why the most distant light you see does not come from stars or galaxies at all, but from a faint background glow, the cosmic microwave background. It is not light from objects, but from a phase transition, a moment when the universe cooled enough to become transparent. That glow is not far away, in the usual sense. It is old, older than stars, older than galaxies, older than everything you think of as structure. The universe allows you to look back almost to the beginning, but it does not allow you to look across, and that distinction is crucial. Looking back in time does not give you access to everything that exists now. It gives you access only to what existed then, and only if its light had a clear path to you. Entire regions of the universe can exist simultaneously with you and yet be invisible forever, simply because their light will never arrive. Distance does not just delay information, it can erase it. This means the universe you reconstruct through observation is not a snapshot. It is a layered archive, a museum where each exhibit belongs to a different century, displayed side by side without labels. You infer sequence, you reconstruct causality, but you never see the full, current state of the cosmos. There is no cosmic present tense available to you. Even the idea of now loses meaning at large scales. Events that are simultaneous for you are not simultaneous elsewhere. The universe does not share your clock. Relativity ensures that time itself depends on motion, gravity, and position. The farther you reach, the less coherent the idea of a universal moment becomes. Light enforces this fragmentation. It prevents the universe from collapsing into a single, shared experience. Every observer carries a different archive, a different history of what reality looks like. From your vantage point, the universe seems ancient, layered, and slow. From another location, the same universe would look different. Some of the galaxies you see would not exist in their sky yet. Others, invisible to you, would dominate their view. Reality does not present itself uniformly. Understanding this changes how you should interpret cosmic images. A deep field photograph is not a census of what exists. It is a time-slice collage assembled from signals that survived a long journey. It is memory, not presence, and memory is incomplete. Some signals fade beyond detectability before they arrive. Some are stretched so much they blend into background noise. Some never had a path that connected them to you at all. The universe does not guarantee that every event leaves a trace you can recover. Light is the fastest messenger available. It is also the slowest limit you cannot surpass. You may imagine future technologies that bypass this constraint, but there is no shortcut. Information cannot outrun light. Causality enforces the speed limit. The universe does not allow updates faster than its own expansion, so you live surrounded by memories. The stars you see have already aged. Some have already died. Some no longer exist in any meaningful sense, yet their images persist, hanging in the sky like echoes. The universe is not showing you what is happening. It is showing you what has already happened, filtered by distance and shaped by expansion. And beyond that archive lies something you cannot access at all. The present state of regions forever out of contact. Light turns distance into time. Expansion turns time into exclusion. What you see is never the universe as it is. It is the universe remembering itself, imperfectly, just long enough for you to notice. A wall is something you recognize immediately. It stops you. It announces itself. It resists your movement and makes its presence obvious. Cosmic expansion does none of these things. There is no surface to touch, no edge to photograph, no sudden obstruction that tells you where motion ends. And yet, expansion becomes a wall, all the same one that cannot be climbed, drilled through, or waited out. To understand this, You have to let go of the idea that expansion is motion through space. Galaxies are not racing away from each other like debris from an explosion. They are not propelled by force. The space between them is changing. New distance is being created everywhere at once. This distinction matters. Because motion can be countered, expansion cannot. If a galaxy were simply moving away, light would still chase it down, given enough time. But when space itself stretches, the road grows faster than the messenger can travel. Light moves forward at the fastest speed allowed by physics, yet finds the finish line receding indefinitely. This is how expansion becomes final. At first, the effect is subtle. Nearby galaxies drift away slowly. Light still crosses the gap. Communication remains possible. The universe feels connected, even generous. But as distance increases, expansion adds more and more separation per unit time. Eventually, there comes a threshold. Beyond that threshold, light can never catch up. This is not because light slows down. It does not. It is because the space it must traverse expands too quickly. Every second of travel adds more distance than the light can close. Progress becomes impossible. Even though motion continues, the wall is not built in front of you. It is built underneath you. Cosmologists call this boundary a cosmic horizon. But the name is misleading. A horizon suggests a line you could reach if only you traveled far enough. This boundary does not work that way. It is not a destination. It is a condition. Once a region of space crosses this condition relative to you, it is no longer part of your causal world. Nothing that happens there can ever affect you. No signal, no force, no information can cross back. And crucially, nothing dramatic marks the moment this happens. A galaxy does not flare or vanish. It does not change direction. From your perspective, it simply fades, growing dimmer as its light stretches thinner. Eventually, the photons arrive so diluted that they blend into the background. Then they stop arriving altogether. The universe does not draw a line and say, beyond this point, nothing counts, is raided. It simply stops delivering updates. This is why expansion is so dangerous to intuition. It does not feel like loss. It feels like quiet continuity. The sky changes slowly. Patterns remain familiar. The process takes billions of years, far longer than any human timescale. But permanence does not require drama. When expansion turns into a wall, it does so without violence. No structure is destroyed. No laws are broken. Nothing collapses. The only thing that disappears is access. You might imagine sending a probe, something physical, to cross this boundary. But that fails for the same reason light fails. The probe would not be moving through static space. The space itself would be stretching beneath it, increasing the distance faster than the probe could close it. There is no route around the wall, because it is not localized. It exists everywhere, encoded into the geometry of space-time. This turns the universe into a patchwork of isolated regions. Each observer has their own causal domain, a bubble of space-time interactions that can affect them and be affected by them. Outside that bubble, reality continues, but without consequence. From within your bubble, the universe appears self-contained, complete, all-encompassing. But this is an illusion produced by geometry. Beyond your horizon, galaxies form stars. Stars collapse, planets assemble, and histories unfold. None of it is recorded in your sky. None of it will ever be. The universe is not partitioned by matter, but by connectivity. This idea runs against centuries of human expectation. Historically, limits were temporary. Mountains blocked paths until someone climbed them. Oceans separated continents until ships crossed them. Distance implied effort, not prohibition. Cosmic expansion introduces a different category of limit, one that effort cannot overcome. You are not failing to reach the rest of the universe. You are forbidden by structure. This has a strange psychological effect. Because the wall is invisible, you continue to imagine the universe as a single, unified arena. Maps show smooth continuities. Simulations extend grids far beyond what can be observed. Equations remain valid everywhere. Mathematically, the universe is whole. Experientially, it is fragmented. This fragmentation increases over time. As expansion continues, more regions slip beyond the horizon. The wall does not stay still. It advances inward, not by moving, but by redefining what counts as reachable. What you can interact with today may be unreachable tomorrow, not because it changed, but because the relationship changed. This makes the wall especially unsettling. It is not fixed. It does not announce its approach. It does not respect landmarks. It simply converts distance into disconnection. From the perspective of the universe, nothing special is happening. Expansion is a smooth, continuous process. From your perspective, reality is quietly being edited. The wall does not separate what exists from what does not. It separates what can matter from what cannot, and that distinction has consequences for knowledge. Science depends on causality. To test a hypothesis, you must observe outcomes. To confirm a theory, signals must travel. Once a region lies beyond the horizon, it is removed from the domain of testable reality, not because it is unknowable in principle, but because the universe refuses to cooperate. No amount of ingenuity can extract information from a region that cannot send information. This does not mean the universe is hostile to understanding. It means understanding has jurisdiction. The cosmic wall is not an error. It is not an anomaly. It emerges naturally from the same laws that allow stars to shine and galaxies to form. Expansion is not a flaw in the universe's design. It is the design, and within that design, isolation is inevitable. The most unsettling realization is not that the universe is expanding. It is that expansion has consequences for meaning. It determines which events can ever become part of your story and which will unfold without witnesses. You are not at the center of this process. Every observer has their own wall, their own horizon, their own limits. There is no privileged location where the universe remains whole. Reality fractures differently for everyone. When expansion turns into a wall, it does not imprison you in a small universe. It reveals that the universe was never fully accessible to begin with. What remains connected feels vast. What lies beyond does not announce its absence. The wall stands not in front of you, but beneath every step you take through space and time, and you cross it without ever noticing the moment you leave something behind. Before humanity understood the universe as vast, it had to accept something more difficult. Depth is not obvious. On Earth, distance announces itself. You feel it in your legs, your breath, the time it takes to arrive. But in the sky, everything looks flattened onto a dome. Stars seem pinned to the same surface, scattered without order or scale. For most of human history, the heavens appeared close, orderly, and complete. The first challenge was not size, it was invisibility. Distance in space does not reveal itself through appearance. A nearby star and a distant one can look identical. Brightness lies. Perspective deceives. The universe offers no natural ruler, no grid lines, no shadows cast by depth. If you want to measure it, you must invent a method where none is given. Early astronomers struggled with this. They tracked motions, cycles, patterns. They mapped positions with remarkable precision. Yet the stars remained fixed to an imaginary sphere. The night sky rotated, but it did not open. Everything felt equally far away because nothing provided a reference. To measure distance, you need parallax, a shift in position when your viewpoint changes. On Earth, this is effortless. Close objects slide against distant backgrounds as you move. But stars are so far away that even Earth's entire orbit around the Sun barely changes the viewing angle. The shift is smaller than intuition can grasp. For centuries, astronomers searched for stellar parallax and found none, not because it did not exist, but because it was too small to detect. The absence of parallax once seemed to imply that the stars were relatively close. The truth was the opposite. They were so distant that human instruments were blind to the effect. Distance hid itself by being too large. When parallax was finally measured, it was not a dramatic discovery. The angles involved were tiny fractions of a degree, then fractions of fractions. A shift so subtle that it could be mistaken for error. But that minuscule movement carried enormous meaning. It proved that stars were not fixed points on a shell. They occupied a three-dimensional space that dwarfed the solar system. This is how the invisible began to yield. From parallax came the first reliable cosmic yardstick, a unit built not on length, but on geometry. A way to turn angles into distances. Suddenly, space had depth. The sky was no longer a painting. It was a volume, but parallax had limits. It worked only for nearby stars. Beyond a certain distance, the shifts became too small even for the best measurements. The universe expanded beyond the reach of the method that revealed it, so new techniques were invented. Astronomers learned to read light as information. They studied how stars pulse, how their brightness changes predictably over time. Certain stars act like cosmic metronomes, their rhythms revealing their true luminosity. By comparing how bright they appear to how bright they truly are, distance can be inferred. Again, the invisible surrendered, but only partially. Each method extended the reach, but also introduced uncertainty. Errors accumulated. Assumptions stacked upon assumptions. Measuring the universe became less like using a ruler and more like reconstructing a scene from echoes. This process demanded humility. You could no longer pretend to know distances directly. You had to trust chains of inference. One measurement depended on another, which depended on another still. The farther you reached, the more indirect your knowledge became. And yet, this indirect approach worked. Galaxies were placed at astonishing distances, millions of light years, then hundreds of millions, then billions. The universe grew not because it changed, but because your ability to measure improved. But measurement does not create access. Knowing that something is far away is not the same as being able to reach it. Measurement tells you where something is relative to you, not whether it can ever affect you. As cosmic expansion asserts itself, this distinction becomes critical. You can measure distances to galaxies that are already beyond your causal horizon. Their light reached you long ago, when they were closer, when the universe was smaller. You assign them positions in a present-day map. But that map is a reconstruction. The galaxies are no longer where you place them. Measurement freezes a past relationship and presents it as structure. This is the quiet irony of cosmology. The better you measure the universe, the more you realize how much of it is inaccessible. Precision sharpens the boundary rather than dissolving it. You can calculate distances with extraordinary accuracy. You can trace the expansion history of space. You can model regions you will never see. But none of this grants entry. The invisible remains invisible in the only way that matters: interaction. The universe allows itself to be measured without allowing itself to be fully known. This forces a re-evaluation of what measurement means. In everyday life, measurement implies control or proximity. You measure land you can walk on. You measure objects you can manipulate. In cosmology, measurement often describes relationships that no longer exist. You measure how far away a galaxy is now, even though you will never observe it as it is now. You measure a distance that no signal can traverse. The number is correct. The connection is gone. This is not a failure of science. It is a revelation about its domain. Science does not promise access to all of reality. It promises consistency. It promises that the same rules apply everywhere, even where evidence cannot reach. Measurement becomes an act of inference grounded in trust. Trust that the universe does not behave differently just because you cannot see it. The invisible becomes real not through observation, but through coherence. This is how humanity learned to live with cosmic limits. By accepting that knowing and reaching are separate things. By understanding that measurement can map a universe larger than experience. Every distance you learn about in space is a reminder of separation. Each number carries an absence within it. The larger the scale, the more complete the disconnection. Yet, without these measurements, the universe would remain shallow and misleading. The sky would still look close. The stars would still feel local. The illusion of intimacy would persist. Measuring the invisible broke that illusion. It replaced comfort with scale, certainty with structure, closeness with context. It taught you that reality does not arrange itself for perception. It must be reconstructed patiently, indirectly, with tools that admit their own limitations. This is the strange success of cosmology. It reveals a universe you cannot fully access, using methods that accept partiality as a condition, not a flaw. The invisible is not empty. It is simply beyond reach. And measurement is how you acknowledge its existence without pretending to cross the distance that separates you from it. There was a time when the universe felt manageable, not small, just contained. The Milky Way was thought to be everything, a vast island of stars, immense by any human standard, yet still comprehensible. Beyond it lay darkness, perhaps thin clouds of gas, perhaps nothing at all. The sky appeared deep, but finite. The cosmos had edges that intuition could hold. Then that picture broke. The break did not come from a single dramatic observation, but from a quiet realization that refused to fit. Certain faint smudges in the sky, objects long catalogued as nebulae, behaved strangely. Their light varied in ways that suggested structure. Their internal motions hinted at size. And most troubling of all, they did not belong. When astronomers began to measure distances more reliably, the implications surfaced slowly, and then, all at once. Those smudges were not clouds within the Milky Way. They were entire galaxies of their own, each containing billions of stars. The universe was not one island. It was an archipelago beyond counting. This was the moment when scales stopped being additive and became multiplicative. The Milky Way did not expand to include these objects. It was demoted, reduced from the universe to one example. Everything familiar shrank in relative importance. The psychological impact of this shift is difficult to overstate. It wasn't just that the universe was larger than expected. It was that human thought had failed to anticipate the correct category of largeness. Intuition had prepared you for more stars, more space, perhaps more complexity. It had not prepared you for repetition at that scale. Galaxies like the Milky Way were not rare exceptions. They were the rule. And then came the second shock. Once galaxies were recognized as separate systems, their behavior revealed something even more unsettling. Their light was shifted, stretched toward redder wavelengths. At first, this was puzzling. Motion could explain it. But the pattern was too consistent. Almost every distant galaxy showed the same effect. The farther away it was, the greater the shift. This was not random motion. It was systematic. The universe was not static. It was expanding. This idea contradicted everything that felt natural. Space had always been treated as a stage on which events occurred, not as an actor in the drama, Expansion suggested that the stage itself was changing, adding distance where none existed before. It also suggested something even more radical. If space is expanding now, it must have been smaller in the past, denser, hotter, more compressed. The universe was not eternal and unchanging. It had a history. Suddenly, the cosmos acquired a timeline. This realization forced a conceptual leap. You could no longer imagine the universe as a fixed container filled with stars. You had to imagine it as a process, one that evolves, stretches, cools, and transforms. Space was not a backdrop. It was a participant. For many, this was harder to accept than the existence of other galaxies. Distance could be added to the map. Expansion rewrote the map itself. The implications cascaded quickly. If the universe is expanding, then distant galaxies are not just far away. They are becoming more distant over time. Relationships change even without motion. Separation becomes dynamic. Thought struggled to keep up. Human intuition is comfortable with growth. Cities expand. Populations increase. Even empires spread. But cosmic expansion does not add content. It adds separation. It increases distance without moving objects through space. It alters geometry without leaving fingerprints you can touch. This is where thought begins to fail, not because it lacks intelligence, but because it evolved for a different environment. Your mind expects causes to look like pushes and pulls. Expansion offers neither. It offers change without force. As the evidence accumulated, resistance faded. The universe was not just larger than imagined. It was governed by rules that did not align with everyday reasoning. The Milky Way became a footnote. Earth became a speck. Human history became a rounding error measured against cosmic time. But those were emotional consequences. The deeper consequence was epistemological. If the universe could expand beyond thought once, it could do so again. The realization planted doubt in the reliability of intuition itself. If scale could betray you at the level of galaxies, what else was being misunderstood? What other assumptions rested on experience too small to matter? The universe had crossed a threshold. It had become larger than any narrative built around centrality or completion. This did not diminish the power of science. It sharpened it. Science did not cling to comfort. It followed evidence even when evidence undermined the mental scaffolding used to interpret it. And the evidence pointed to a universe that did not align with human preference. From that moment on, cosmology could no longer promise a complete picture. It could promise coherence, laws that apply everywhere, patterns that repeat, relationships that hold even where observation fades. But the idea that the universe could be contained within thought was gone. The night sky still looks calm. Stars still appear fixed. The Milky Way still arches overhead with quiet grandeur. Nothing about the visual experience warns you of the conceptual rupture beneath it. That is the strange part. The universe became larger than thought without becoming louder. No sensation marks the boundary where intuition fails. You cross it by learning, not by traveling. One day, the sky feels familiar. The next, it becomes evidence of your limitations. This moment, the recognition of other galaxies, of expansion, of scale beyond anticipation, was not just a discovery. It was a redefinition of what discovery means. You no longer uncover a universe waiting to be known in full. You investigate one that will always exceed the frameworks used to describe it. The universe does not adjust to your understanding. Understanding must stretch, often painfully, to keep up. And even then, it falls short. This was the moment the universe became bigger than thought, not because it grew, but because thought reached its natural edge. Beyond that edge lies not ignorance, but humility, the acceptance that reality does not arrange itself to be grasped, only to be glimpsed, briefly, through structures that must constantly be revised. And that revision never ends. A horizon feels like a place, a line you could approach, a distant edge waiting to be reached. Cosmic horizons are nothing like that. They are not locations in space. They are conditions imposed by time, motion, and geometry. You do not travel toward them. They emerge around you as the universe evolves, quietly deciding what can still matter to you and what never will again. To understand their birth, you must abandon the idea that the universe offers unlimited access given enough patience. Patience works only in a universe that stands still. Ours does not. From the earliest moments after the universe became transparent, light began to travel outward in all directions. At first, distances were small. Space was dense and compact. Signals crossed vast regions with ease. Everything was close enough to remain connected. Then expansion took over. As the universe grew, distances increased. Light still moved outward, but the terrain beneath it stretched. Early on, this stretching was slow enough that light could keep up. Signals emitted anywhere could, in principle, reach anywhere else given sufficient time. That condition did not last. As expansion continued, a subtle threshold was crossed, not everywhere at once, not suddenly, but inevitably. Beyond a certain distance, expansion added separation faster than light could close it. From that moment, a horizon was born. Nothing dramatic marked the transition. No explosion, no fracture, no visible boundary. Connectivity simply failed. This is what makes cosmic horizons so unsettling. They are not barriers you collide with. They are relationships that quietly dissolve. Two regions of space can exist, both perfectly real, both evolving normally, yet forever unable to influence one another. The universe does not tear itself apart. It grows into isolation. There are different kinds of cosmic horizons, but they share a common theme: limits on causality, limits on what can affect what, limits on which events can ever become part of your history. One horizon marks the furthest light that has reached you since the beginning. Another marks the furthest light that ever will. Between those two boundaries lies everything you can know. Outside them lies everything else. The birth of cosmic horizons turns the universe into a collection of overlapping but incomplete realities. Each observer carries their own causal bubble, centered not in space, but in experience. From inside that bubble, the universe feels whole. From outside, it is irrelevant. This is not solipsism, it is geometry. The most counterintuitive aspect is that horizons are observer-dependent. There is no single cosmic horizon shared by all. Move to another galaxy, and the contents of your observable universe change. Some things you see would be gone. Other things, invisible to you, would dominate that sky. Reality has no master copy. This destroys the idea that the universe can ever be fully mapped from a single vantage point. No observer sees everything that exists, or even everything that exists nearby in an absolute sense. Each perspective comes with built-in exclusions, and those exclusions grow over time. As expansion continues, horizons advance. Regions that were once connected drift beyond reach. Events that could once have influenced you lose that ability forever. The universe does not erase them. It removes the possibility of interaction. This introduces a permanent asymmetry into time. You can remember the past. You can receive signals from earlier eras, but you cannot restore lost connectivity. Once a region crosses your horizon, no future action can bring it back. No technology can reverse the geometry. No patience can overcome it. The universe allows memory, not reunion. This has consequences for how history is written. Cosmic history is not the story of everything that happened. It is the story of what left traces that could reach us. Countless events occurred beyond our horizon without witnesses, without records, without impact on anything we can observe. They are not hidden chapters. They are unwritten ones. Science often prides itself on universality. The same laws apply everywhere, and that remains true. But application does not imply accessibility. Laws govern regions that will never contribute evidence to your theories. You believe in their existence not because you can test them directly, but because the structure of the universe demands consistency. Cosmic horizons force science to operate without completeness. This does not weaken science. It defines its scope. The birth of horizons marks the moment when the universe stopped being a single, connected experiment and became a collection of isolated trials running in parallel, never sharing results. Each region follows the same rules, yet evolves in solitude. From within your horizon, the universe feels vast and richly detailed. Galaxies cluster. Light streams in from deep time. Patterns emerge. It feels like abundance, but abundance hides subtraction. For every galaxy you see, others have already slipped away. For every signal recorded, others failed to arrive. The sky does not display absences. It only displays what survived. This creates a dangerous comfort. You assume that what you see is representative, that your patch of reality is typical. That extrapolation is safe. Horizons undermine that assumption. They guarantee that large portions of reality are statistically invisible, not because they are rare, but because they are disconnected. Any conclusions drawn from within your horizon are necessarily provisional, shaped by selection effects imposed by geometry. You do not sample the universe. The universe samples you. This realization changes the tone of cosmology. It shifts the discipline from conquest to interpretation, from accumulation to acceptance. You are not collecting all the pieces. You are working with what remains reachable, and what remains reachable shrinks over time. The birth of cosmic horizons ensures that the universe grows quieter, not louder, less connected, not more. Communication windows close. Mutual influence fades. Isolation increases, not through catastrophe, but through success, through expansion, proceeding exactly as the laws predict. The universe is not hostile to connection. It simply does not prioritize it. There is no moment when the horizon announces itself. You do not feel it arrive. You infer it after the fact, by noticing what no longer changes, what no longer responds, what no longer sends anything new. By the time you realize a region is beyond reach, it has already been gone for longer than human history. This is the deepest discomfort of cosmic horizons. They deny you the drama of loss. They deny you even the clarity of farewell. Things do not leave. They stop being able to arrive. And the universe continues, vast and indifferent, carrying on countless stories that will never intersect with yours. The birth of cosmic horizons marks the end of the idea that reality is fully shared. From that moment on, the universe becomes something else, not a single conversation, but many monologues unfolding side by side, unheard by one another. You live inside one of them, and you will never know how many others exist beyond the edge of your ability to listen. What remains visible feels permanent, not because it truly is, but because it still answers when you look. The galaxies you can see today belong to a shrinking category, structures that have not yet slipped beyond the limits of contact. They are close enough, in a cosmic sense, for their light to continue arriving. They still participate in your version of reality. They still leave fingerprints on your instruments. This creates a subtle illusion of stability. When you observe the Milky Way, its spiral arms stretching across the sky, it feels timeless. The stars appear fixed, arranged into patterns that seem ancient and enduring. Even distant galaxies, resolved as faint smudges or elegant spirals, give the impression of a universe filled with long-lived architecture. But visibility does not imply permanence. These structures are not static monuments. They are temporary arrangements. held together by gravity in a universe that increasingly favors separation. Their continued presence in your sky is not guaranteed by size or mass, but by timing. They are visible because they have not yet crossed the threshold where expansion wins. Galaxies form groups and clusters because gravity can still overpower expansion at small enough scales. Within these regions, matter collapses, stars ignite, systems orbit, and structure persists. The Milky Way belongs to such a group, a local collection of galaxies bound tightly enough to resist being torn apart by the stretching of space. This is why nearby galaxies drift slowly relative to one another instead of vanishing immediately. Gravity creates pockets of resistance, islands where expansion is locally defeated. For now, these pockets are what give the universe texture. They provide the scaffolding on which everything familiar depends. Stars are born in galaxies. Planets form around stars. Life emerges on planets. Meaning accumulates in places where structure survives long enough to matter. From your vantage point, these structures define reality. You map them. You name them. You trace their motions. You reconstruct their histories. The cosmic web appears intricate and richly connected. Filaments of matter linking clusters across vast distances. It feels like a grand design, woven carefully across the sky. But even this web is fragile. At the largest scales, gravity struggles. Clusters of galaxies cling together, but clusters do not bind into ever larger wholes indefinitely. Expansion dilutes the connections. Filaments thin, distances widen. The cosmic web stretches until its threads no longer transmit influence. The structures you can still see represent a transitional phase. They exist at a moment when gravity and expansion are delicately balanced. Too early in the universe's history, and structures had not yet formed. Too late, and expansion dominates, isolating each gravitational island completely. You live in the narrow window where structure is abundant and visible. This makes the present universe feel rich, almost generous, but that richness hides a countdown. Each galaxy you see is aging, not just internally, as stars exhaust their fuel, but externally, as the space between galaxies grows. Over time, distant structures will fade, not because they change, but because their light becomes too stretched, too diluted to detect. Visibility ends quietly. The structures closest to you will endure the longest. The Milky Way and its immediate neighbors will remain bound, orbiting and eventually merging. These local events will continue long after distant galaxies have vanished from view. The sky will simplify, patterns will dissolve. Future observers, if any exist, will see a quieter universe, not emptier in absolute terms, but emptier in accessible structure. This is why the structures you can still see matter so much. They are not just objects of study. They are a record of a universe still willing to reveal itself. Each visible galaxy is a message that arrived before the channel closed. When you look at a cluster of galaxies, you are not just observing mass and motion. You are witnessing a victory over expansion that will not last indefinitely. Gravity has carved out a temporary refuge, a region where interaction still outweighs separation. These refuges define the observable cosmos. They also distort your sense of scale. Because structure clusters matter, it creates the impression that the universe is more connected than it truly is. You see chains of galaxies and assume continuity. You see filaments and imagine permanence, but the connectivity you observe is local, not global. Beyond the structures you can see lies a vastness without pattern, not because patterns do not exist, but because they no longer connect to you. The universe outside your horizon may be filled with galaxies arranged in similar webs, following the same laws, repeating the same motifs, but repetition without connection leaves no trace. What you see is not representative of everything. It is representative of what remained reachable. This reframes observation itself. Telescopes do not reveal the universe as it is. They reveal the universe as it was, filtered by which structures managed to stay in contact long enough to be recorded. Every map of the cosmos is shaped by survival bias. The structures you can still see are the ones that beat the odds. They were close enough, dense enough, early enough. Others existed and still exist. But they fell behind the expanding geometry before their light could complete the journey. They are absent not because they are rare, but because they were unlucky in time and distance. This is why abundance in the sky should be interpreted carefully. A sky filled with galaxies does not imply a universe that is fully visible. It implies a universe caught mid-transition, where access has not yet collapsed entirely. The present moment is deceptive. Structure gives comfort. It suggests order, continuity, a universe that can be understood by accumulation. But structure is also temporary. It exists in defiance of expansion, not in harmony with it. Over long timescales, expansion wins. The structures you can still see are already being sorted. Some will remain bound to you forever. Others will drift beyond reach, leaving behind only older and older light, stretched thinner with each passing epoch. Nothing signals the moment a structure stops being relevant to your future. No alarm sounds when a galaxy becomes unreachable. It simply stops contributing new information. The sky does not show you what it has lost. It only shows you what remains. And what remains feels complete only because you cannot see the absence surrounding it. The structures you can still see are precious, not because they are rare in the universe, but because they are rare in your experience of it. They represent the last shared architecture between you and a cosmos that is steadily fragmenting. They are the final witnesses to a time when the universe was still connected enough to be mistaken for whole. And their quiet persistence is what makes the loss beyond them so easy to overlook. At first glance, the universe looks scattered. Stars appear isolated. Galaxies seem sprinkled randomly across the sky. Distance creates the illusion of chaos. Then patterns emerge. When astronomers began mapping galaxies in 3 dimensions, something unexpected appeared. Matter was not distributed evenly. It gathered. It connected. It traced enormous shapes that stretched far beyond individual galaxies or clusters. The universe revealed a structure so vast that it could not be seen from any single vantage point. This structure became known as the cosmic web. It is not a web in the everyday sense. There are no threads you could touch, no knots you could isolate. It is a statistical pattern, a consequence of gravity acting over immense scales. Galaxies collect along filaments of invisible matter, leaving behind enormous voids where almost nothing forms. From far enough away, the universe resembles a sponge or a neural network, dense intersections linked by elongated strands, separated by regions of emptiness that dwarf anything familiar. This organization did not require design. It emerged naturally from small fluctuations in the early universe, amplified over billions of years by gravity. Tiny differences in density grew into filaments. Filaments fed clusters. Clusters anchored superclusters. The web formed not because matter wanted to connect, but because gravity rewards proximity. Superclusters are the largest identifiable features in this architecture. They are not tightly bound like galaxies or clusters. They are loose associations, regions where gravity once had enough influence to guide matter into shared flows. They are patterns of motion more than objects. From within one, everything feels local. From outside, the coherence fades. This is where scale begins to distort intuition again. Superclusters can span hundreds of millions of light years. They contain tens of thousands of galaxies, each with billions of stars. Yet even at this scale, gravity struggles. Superclusters are not permanent structures. They are transitional arrangements. snapshots of matter still responding to ancient conditions. Beyond them, expansion takes over. The cosmic web does not fill the universe. It occupies only the regions where matter was dense enough to slow separation. The voids between filaments grow larger over time. They do not collapse. They expand, stretching space until the web thins and connectivity weakens. From your position, the web feels stable because change is slow. The filaments do not snap. The clusters do not scatter overnight. But the process is relentless. The web is not being destroyed. It is being diluted. This is the subtle tragedy of large-scale structure. The universe built something intricate and then began pulling it apart without breaking it. The patterns persist just long enough to be observed, then fade from relevance. Superclusters illustrate this perfectly. They look like the ultimate level of organization, the largest meaningful grouping of matter, but they are already past their peak. They are no longer forming. They are dissolving. The reason is simple. Gravity operates at the speed of light, mediated by the curvature of space-time. Expansion operates everywhere at once. As distances grow, the ability of gravity to coordinate motion across vast regions weakens. Eventually, it loses. This does not happen abruptly. Superclusters do not explode. Their galaxies simply stop responding to one another. Motions that once pointed inward flatten out. Flows that once converged stall. What remains is a fossil pattern, visible but no longer dynamic. The cosmic web becomes a memory. From within a filament, it still feels connected. You can trace galaxy after galaxy, cluster after cluster, forming a chain that seems to imply continuity. But that continuity is historical. It reflects conditions that no longer apply. The web is the universe, remembering how it once behaved. This memory is misleading. It suggests that structure exists at all scales, that if you zoom out far enough, connectivity always reappears. In reality, there is a cutoff. Beyond a certain scale, expansion erases coherence entirely. There is no larger web binding superclusters into a greater whole. This is not a limitation of observation. It is a feature of reality. The universe organizes itself up to a point, then stops. What lies beyond the web is not chaos, but independence. Regions evolve without reference to one another. Patterns repeat, but they do not interact. The universe becomes a collection of similar stories unfolding without contact. This is why the cosmic web is both beautiful and deceptive. It gives the impression of unity in a universe that is becoming fragmented. It tempts you to believe that everything is part of one grand structure, when in fact that structure is already breaking apart. The scale at which the web dissolves marks the boundary between shared history and separate futures. Inside the web, galaxies once influenced one another. Outside it, they never will. This reframes how you should interpret cosmic maps. When you see filaments stretching across space, you are not seeing a living network. You are seeing the frozen imprint of an earlier era, preserved just long enough to be recorded. The web does not represent the future of the universe. It represents its past. As time continues, the filaments will thin. Clusters will drift out of coordination. Superclusters will cease to have meaning beyond local descriptions. Eventually, each gravitational island will exist alone, surrounded by expanding voids. The universe will not lose its laws. It will lose its connectivity. This is the ultimate fate implied by the cosmic web. It shows you the larger scale at which matter ever meaningfully organized itself. Beyond that, expansion forbids further assembly. The web is not a triumph of structure. It is a limit case. And like all limits in cosmology, it does not announce itself. It simply exists, quietly defining what the universe allows and what it does not. When you admire the cosmic web, You are looking at the last stage of large-scale cooperation, a moment when gravity still mattered across immense distances. Before expansion turned those distances into silence, the universe allowed this pattern to form, then it began to let it go. What you see now is not the web at its height, but at its threshold still visible, still intricate, already fading into irrelevance. The cosmic web is not the universe's skeleton, it is its echo. Maps are meant to grow. Each generation expects to add detail, extend borders, fill blank spaces with names and measurements. In human history, progress usually meant expansion, more territory known, more routes traced, more places connected. The cosmic map does the opposite. As time passes, the universe removes places from your map, not by erasing them from existence, but by severing the paths that once allowed them to matter to you. What remains is not a clearer picture of everything, but a narrower picture of what can still be connected. This is the shrinking map of reality. At first, it feels counterintuitive. Telescopes improve, surveys deepen, instruments become more sensitive. You detect fainter galaxies and map structures farther away than ever before. On the surface, knowledge expands, but the surface is misleading. The true boundary of relevance is not what you can detect today. It is what can still exchange information with you over time. And that boundary is contracting every moment. Distant regions cross a threshold beyond which no new signals will ever arrive. The last light from those places may already be on its way, stretched thin and red-shifted, carrying the final update you will ever receive. After that, silence. The map does not tear, it fades. This kind of loss is difficult to register because it leaves no gap. The sky does not darken where a region becomes unreachable. Nothing vanishes abruptly. You simply stop receiving anything new from that direction. The last message arrives, and then there are no more. From your perspective, the universe looks stable. Galaxies remain where they are. Patterns persist. The map appears intact, but it is quietly becoming outdated. What you see is increasingly archival. Cosmological maps often show the universe as a vast, continuous volume, with structures extending far beyond what you can ever observe. These maps are mathematically valid. They follow the laws that govern expansion and structure formation. But they can be deceptive if taken as representations of lived reality. They show where things are inferred to be, not where interaction is possible. The shrinking map is not about ignorance. It is about jurisdiction. Certain regions of space fall outside the domain, where cause and effect can operate across distance. They remain real, governed by the same physics, but excluded from influence. This introduces a strange asymmetry into knowledge. You can know about regions you can never affect or be affected by. You can describe their likely properties, simulate their behavior, and place them on a conceptual map, but they will never respond. They will never correct you. They will never send confirmation. The map becomes theoretical long before reality ends. This separation matters because science relies on feedback. Hypotheses gain strength through repeated interaction between prediction and observation. When regions cross beyond the horizon, that loop breaks. You may have a model, but you lose the possibility of new evidence. The universe does not stop existing. It stops participating. This is why the shrinking map is not a failure of exploration. It is a feature of the environment. No amount of effort can keep regions connected once expansion carries them beyond reach. The loss is not due to neglect or limitation of tools. It is enforced by geometry. You can think of it as a library where books continue to be written, but the doors to new wings slowly lock. The texts still exist. They simply cannot be retrieved. The unsettling part is how early this process begins. The universe is not waiting until the distant future to close connections. It has been doing so for billions of years. Many regions that once could have exchanged information with us already cannot. Their stories are finished from our point of view, even as they continue elsewhere. This means that cosmic history, as you can tell it, is already incomplete. When you reconstruct the past of the universe, you do so using signals that survived long journeys through expanding space. But countless other signals failed to arrive. They were not blocked or destroyed. They were outpaced. History favors messages that started early and close. As the map shrinks, selection effects grow stronger. The universe you can study becomes less representative of the universe that exists, not because the laws change, but because the sample becomes biased toward what remained nearby enough to stay connected. This bias is not random. It is systematic. Over time, your accessible universe becomes dominated by local structures. Your galaxy, your group, your cluster, distant variety fades. The sky simplifies. From within that simplification, it is easy to mistake the remaining view for the whole. The map still looks complete, just smaller. The missing regions leave no outline. This is the danger of the shrinking map. It does not feel like loss. It feels like normalization. The universe becomes easier to describe, not because it is simpler, but because complexity has drifted out of reach. The remaining structures interact frequently. Their behavior is well sampled. Patterns repeat. Knowledge appears to stabilize, even as relevance narrows. Future observers, if they exist, will inherit this narrowed map. They will see a quieter cosmos, dominated by local interactions. The evidence for large-scale structure may be faint or absent, without records, without relic signals. They may not know what was lost. The map will not tell them. This perspective reframes the present moment. You live at a time when the cosmic map is still richly populated. Distant galaxies still send light. Large-scale patterns are still visible. The universe has not yet reduced itself to local familiarity. This is not a permanent condition. But even now, the shrinking has begun. Each second removes potential from the map, even as observation adds detail within the remaining domain. Expansion edits faster than discovery can compensate. The universe does not wait for understanding. The shrinking map of reality teaches a difficult lesson. Knowledge is not guaranteed to accumulate indefinitely. It can peak, it can plateau. It can even decline not through forgetting, but through disconnection. This does not render science meaningless. It gives it urgency. The map you draw today captures relationships that will never be visible again. The structures you chart are not just objects. They are the last witnesses of a time when the universe was more connected than it will ever be again. Every cosmic survey is also a preservation effort. The universe is not hiding its territory. It is withdrawing access, and the map responds accordingly. Not with missing regions, but with a gradual narrowing of what counts as reachable reality. What remains on the map feels solid. It feels sufficient, but its completeness is an illusion sustained by silence. The shrinking map does not announce its progress. It simply leaves fewer places where answers can still arrive. Some messages arrive late, others arrive only once, and some arrive so faint, so brief, that they feel less like communication and more like a mistake the universe never corrects. These are the signals that almost reached us. They sit at the edge of detectability, brushing against our instruments just long enough to leave a question behind. They do not repeat on demand. They do not offer clarification. They do not fit comfortably into models. They are fragments, evidence of events that occurred far away, long ago, under conditions we can no longer recreate. In a universe defined by expansion and horizons, this is exactly what you should expect. Signals are not guaranteed to arrive intact. They weaken as space stretches. Their energy thins. Their timing smears. By the time they reach you, they may be shadows of their original form, stripped of context and clarity. The universe does not preserve messages for convenience. It delivers whatever survives the journey. Sometimes, that survival window is narrow. Consider a radio signal that appears suddenly, holds for a moment, and vanishes forever. No repetition, no follow-up, just a brief alignment of conditions that allowed information to slip through before geometry closed the door. From your perspective, it feels tantalizing. From the universe's perspective, it is ordinary. Most signals do not get a second chance. The difficulty lies in interpretation. Science thrives on repetition. Patterns build confidence. Single events breed uncertainty. When a signal arrives only once, you are left with an uncomfortable choice: treat it as noise, or accept that some real phenomena do not repeat on human timescales. The universe is under no obligation to accommodate your need for verification. Signals that almost reached us expose the tension between evidence and expectation. You want clean data, consistent sources, controllable experiments. The cosmos offers transient encounters shaped by expansion, distance, and chance. By the time you notice something unusual, the conditions that produced it may be gone. This is especially true for signals that originate near the limits of connectivity. At extreme distances, the universe becomes a filter. Only certain wavelengths survive. Only certain energies remain detectable. Timing becomes critical. A signal emitted too late, or from too far away, never arrives at all. One emitted early enough may arrive weakened, stretched, distorted, barely recognizable as a signal. In that sense, every detection is already biased toward what could endure. Some signals arrive just before the cutoff. Their sources are now beyond reach. You receive a final update from a region that has already crossed your horizon. After that moment, nothing more can come. The signal is not a beginning, it is an ending. This changes how you should think about cosmic messages. They are not conversations. They are postcards sent before the address stopped working. This applies not only to radio signals, but to any information traveling across expanding space. Light from distant galaxies carries images of structures that no longer exist in the same form. Spectral lines reveal chemical compositions that have since evolved. Motion inferred from redshift describes relationships frozen in time. You are always receiving outdated information. Sometimes, that delay produces confusion. A signal may appear anomalous not because it is exotic, but because you are missing context. You see an effect without access to the conditions that caused it. The universe does not include footnotes. In other cases, the confusion comes from rarity. Some events are genuinely uncommon. They occur under specific circumstances that may never repeat within your observable domain. Expansion ensures that even if they happen elsewhere, their signals may not reach you. Rarity and disconnection combine to create mystery. This is why the universe feels filled with unresolved questions, not because answers do not exist, but because the pathways that carry answers are fragile. They depend on timing, distance, and geometry aligning just right. When that alignment fails, curiosity remains unsatisfied. There is a tendency to treat near-miss signals as invitations to assume that if something almost reached us, it must be trying to. This is a projection. The universe does not aim messages. It produces events. Signals are a side effect. Meaning is something you assign after the fact. This realization can feel disappointing. It removes intention. It strips away narrative comfort. But it also restores realism. The cosmos is not whispering secrets. It is operating according to rules that do not prioritize your curiosity. Signals that almost reached us are reminders of this indifference. They also reveal the fragility of evidence. A slight change in expansion rate, a slightly greater distance. A slightly later emission, and the signal would never have arrived. You would not know it was missing. You would not know anything happened. Absence leaves no trace. This is the most unsettling aspect. You can never know how many signals failed completely. You can only catalogue the survivors. The universe you study is built from what made it through a hostile environment of stretching space and limited speed. Every detection is a success story. Every mystery is a partial success. From this perspective, it becomes clear why some questions remain open indefinitely. The information required to resolve them may no longer be accessible. The relevant signals may have already passed, or may be en route but too degraded to interpret. The universe does not guarantee closure. This does not invalidate scientific effort. It reframes it. Science becomes an exercise in inference under constraint. You work with incomplete records. You weigh probabilities. You acknowledge uncertainty, not as failure, but as an honest reflection of the environment. Signals that almost reached us sit at the boundary of that effort. They are reminders that knowledge has conditions, that access is temporary, that not everything that happens can become part of shared understanding. In human terms, they resemble messages sent from places that no longer exist on the map. You receive a fragment of a story without knowing its ending, or even its beginning. You cannot reply. You cannot ask for clarification. You can only analyze what arrived, and then you wait. Often, nothing more comes. This waiting is not passive. It shapes how you think about the universe. It forces restraint. It discourages overconfidence. It reminds you that the absence of follow-up is not evidence of insignificance. Some events matter enormously, yet leave behind only a whisper. As expansion continues, these near-miss signals will become more common relative to complete ones. The window for information exchange narrows. The universe grows quieter, not because fewer things happen, but because fewer things can be heard. You are living during a period when some long-distance signals still manage to arrive, when the sky still speaks, even if softly. This will not always be the case. Signals that almost reached us are the last echoes of a more connected cosmos. They do not point toward answers, they point toward limits, and in doing so, they teach you something essential. The universe is not obligated to explain itself fully, only to be consistent while it remains within reach. Everything else unfolds in silence. Beyond the range where questions can follow, there are places where nothing will ever be seen. Not because they are hidden, but because no line of sight can ever connect them to anyone else. This is the idea that unsettles most people. Even those comfortable with cosmic scale, a universe without witnesses feels incomplete, almost illegitimate. If no one can observe an event, record it, or be affected by it, the instinct is to question whether it truly matters. The universe does not share that instinct. Reality does not require an audience. As expansion pushes regions beyond all possible horizons, vast portions of the cosmos become causally isolated. In these regions, stars ignite, planets assemble, and galaxies evolve exactly as they do here. Physics continues uninterrupted. Time passes. Structure forms and dissolves. The only difference is that none of it can ever intersect with another story. These regions are not dark because something went wrong. They are dark because nothing can arrive to illuminate them from the outside. And nothing they emit can escape. They exist without consequence. This challenges a deeply human assumption, that existence and observation are inseparable. On Earth, almost everything that matters leaves traces, footprints, records, memories. If something leaves no trace, it feels as if it never happened. The universe operates on a different standard. In cosmology, observation is a privilege granted by geometry, not a prerequisite for reality. Events do not wait to be seen. They do not announce themselves. They unfold according to local conditions, regardless of whether those conditions ever connect to anything else. A universe without witnesses is not empty. It is indifferent. This indifference forces a re-evaluation of what science can claim. Science depends on evidence, and evidence depends on interaction. If a region of space cannot send or receive information, it cannot contribute evidence. It cannot confirm theories or challenge them. It exists beyond the reach of experimentation, and yet, it is still governed by the same laws. This is not speculation. It is inference grounded in consistency. The same expansion that isolates regions here operates everywhere. The same physics that produces stars and galaxies locally should operate in regions forever cut off from us. To assume otherwise would require special pleading that the universe behaves differently where we cannot see it. There is no reason to believe that. The universe does not change its rules for convenience. This creates a strange asymmetry in knowledge. You can describe the universe in general terms, confident that the laws apply universally, while accepting that most specific events will never be known. You know how stars form, but you will never know how most stars formed. You know how galaxies evolve, but you will never witness the histories of most galaxies. General knowledge expands, particular knowledge vanishes. This is the cost of cosmic scale. A universe without witnesses also disrupts the narrative comfort of progress. It is tempting to imagine that, given enough time, intelligence spreads, observation increases, and the universe becomes more thoroughly known. Expansion undermines this vision. It ensures that even if intelligence arises in many places, those intelligences will become increasingly isolated. They will not share discoveries. They will not compare maps. They will not confirm one another's existence. Each will live inside a shrinking bubble of relevance, mistaking its local universe for something closer to complete than it truly is. From the inside, isolation is invisible. This invisibility is what makes the idea so difficult to accept. You do not experience the loss of unreachable regions. You experience continuity. The sky still contains stars. Galaxies still glow. The universe still feels present. The absence of witnesses elsewhere leaves no mark here. The universe does not mourn its own fragmentation. In a universe without witnesses, countless events unfold without ever becoming facts. They happen, but they never enter a shared record. They leave no fossils, no radiation, no imprint that can be decoded from afar. Their only significance is local. This does not make them less real. It makes them irrelevant to anything beyond their immediate surroundings. Relevance is not a property of existence. It is a property of connection. This distinction is crucial. It means that meaning, at least in the scientific sense, is constrained by geometry. Not everything that exists can matter to you. Not everything that matters locally can matter universally. The universe enforces parochialism. This is uncomfortable because it strips away the idea that the cosmos is one grand, shared story. Instead, it becomes a patchwork of isolated narratives, each internally consistent, externally silent. There is no cosmic archive where all events are stored. There is no final accounting. What happens beyond horizons is not waiting to be discovered later. It is permanently outside the story. This realization also changes how you should interpret absence. When something cannot be observed, it is tempting to treat it as hypothetical. But beyond cosmic horizons, absence is not uncertainty. It is inaccessibility. The difference matters. Uncertainty invites resolution. Inaccessibility does not. The universe without witnesses is not incomplete. It is simply unconcerned with being known. It does not organize itself around observers. Observers are latecomers, emerging briefly in pockets where conditions allow complexity and connection. Those pockets are temporary. As expansion continues, Even the regions that now host observers will drift into isolation. Communication will narrow. Shared evidence will disappear. The universe will not become empty. It will become locally sufficient and globally silent. This does not mean that inquiry is pointless. It means that inquiry has a domain. You are allowed to ask questions only where answers can still arrive. Beyond that, the universe offers no response, not out of hostility, but because the structure of space-time forbids exchange. A universe without witnesses is not a failure of intelligence. It is the natural outcome of a universe that values consistency over accessibility, and in that universe, existence is not validated by being seen. It simply is. The most difficult part is accepting that this has always been true. Even now, while you read this, vast regions of reality are unfolding without any possibility of ever being noticed. They are not waiting for discovery. They are already beyond it. You live in a universe where most events will never be part of anyone's knowledge. Not because knowledge is weak, but because connection is rare, and rarity, not mystery, is what ultimately defines the limits of what can be known. You do not experience the universe as it is. You experience the part of it that can reach you. This sounds obvious, almost trivial, until you realize how much weight that sentence carries. Every thought you form about reality is shaped by access. Every conclusion rests on what information survives the journey to you. The universe you inhabit is not false, but it is incomplete, and it always has been. Living inside a partial reality does not feel like deprivation. There is no sensation of something missing. The sky does not appear cropped. The laws of physics do not stutter at the edge of your awareness. From within your causal bubble, everything appears continuous, coherent, sufficient. That is what makes partiality so convincing. Human perception evolved to treat experience as representative. What you see feels like what exists. What you can interact with feels like what matters. This works well on Earth, where distances are small and connections are dense. It works poorly in a universe where connectivity is temporary and exclusion is structural. The partiality of reality is not a bug. It is a condition imposed by scale. Every observation you make is local in the deepest sense. Even when you look across billions of light years, you are still confined to a narrow slice of what exists. The universe allows you to sample it, not survey it, and the sample is shaped by timing, distance, and expansion, not by fairness or completeness. This creates a quiet tension at the heart of knowledge. On one hand, science strives for universality. The laws you uncover here are assumed to apply everywhere. Gravity behaves the same beyond your horizon as it does within it. Nuclear processes do not change their rules when they drift out of reach. Consistency holds. On the other hand, the evidence that supports those laws is gathered from a shrinking domain. Over time, the accessible universe becomes less diverse, not because reality simplifies, but because variety drifts beyond connection. You live inside a universe that becomes more predictable as it becomes less representative. This is an uncomfortable trade. It challenges the idea that knowledge naturally accumulates toward completeness. Instead, knowledge becomes increasingly refined within an increasingly narrow context. You know more about less. Precision increases as scope contracts. From the inside, this feels like progress. From the outside, it is a narrowing of perspective. Living inside a partial reality also affects how you interpret absence. When something cannot be observed, the instinct is to label it unknown, uncertain, unresolved. But beyond cosmic horizons, absence is not uncertainty. It is exclusion. There is no future observation waiting to resolve the gap. This distinction matters because it changes how questions function. Some questions invite answers, others do not. Not because they are ill-posed, but because the universe has removed the conditions required to answer them. Asking what happens beyond your horizon is not forbidden. It is simply disconnected from evidence. The universe does not reject curiosity. It ignores it where geometry forbids response. This forces a shift in intellectual posture. You move from expecting resolution to accepting limits. Not temporary limits, but permanent ones. Not obstacles to be overcome, but boundaries to be respected. This acceptance is not resignation. It is realism. Living inside a partial reality does not mean abandoning ambition. It means understanding the terrain ambition operates within. You can still ask profound questions. You can still build models that extend beyond observation. But you do so knowing that some aspects of reality will never confirm or deny your conclusions. You work with coherence instead of closure. This also reframes meaning. If most of the universe will never be known, does that diminish the value of what is known? Intuitively, it might feel that way. If your access is limited, perhaps your conclusions are provisional, fragile, insignificant, but meaning does not require totality. A book does not need every page to be meaningful. A life does not need to witness all events to matter. Understanding does not require omniscience to be valid. It requires consistency, honesty about limits, and relevance within context. Your context is partial. That does not make it arbitrary. The structures you can observe still follow laws that apply everywhere. The processes you study still reflect universal principles. The fact that you cannot see everything does not undermine what you can see. It simply prevents you from mistaking the part for the whole. This distinction guards against arrogance. Living inside a partial reality encourages humility not as a moral virtue, but as a logical necessity. When access is limited, certainty must be proportional. Claims must be bounded. Confidence must coexist with restraint. The universe does not punish overconfidence. It simply outpaces it. There is also a human dimension to this realization. People often fear insignificance in a vast cosmos, but partiality reframes that fear. You are not insignificant because the universe is large. You are significant because your window into it is rare. You exist during a time when the universe is still connected enough to be studied, when signals still arrive from deep time, when structure is still visible across immense scales. This is not a permanent state. Living inside a partial reality gives your moment weight, not because it is central, but because it is fleeting. The ability to reconstruct cosmic history, to see large-scale structure, to infer origins, all of this depends on conditions that will not last indefinitely. Your partial reality is not static, it is transitional. This does not demand urgency in the dramatic sense. It invites care in how knowledge is preserved, care in how conclusions are framed, care in how the universe is described to those who come after, who may inherit a quieter sky and fewer clues. To live inside a partial reality is to accept that understanding is local, provisional, and precious. You are not entitled to everything that exists. You are responsible for what you can reach. The universe does not promise wholeness. It offers coherence within bounds. And within those bounds, meaning is not diminished by incompleteness. It is sharpened by it. You do not stand outside reality, looking in. You stand inside a fragment of it, large enough to inspire wonder, small enough to demand humility. That fragment is not a mistake. It is where thought is allowed to exist at all. Living inside a partial reality does not make your understanding false. It makes it honest. And honesty, in a universe defined by limits, is the closest thing to completeness you will ever have. The end of the universe does not arrive with fire. It does not announce itself with collapse, violence, or noise. It arrives quietly, as a loss of information. For most of human history, the idea of progress was tied to accumulation. More land explored, more knowledge gathered, more connections made, The future was imagined as an expansion of understanding, a widening of perspective, a steady march toward completeness. The universe does not share this trajectory. In cosmic terms, the future holds less to know, not more. As expansion continues, the sky simplifies. Distant galaxies fade from view. Large-scale structure dissolves into isolation. Signals stop arriving, not because events stop happening, but because distance turns into prohibition. The universe does not erase complexity, it removes access to it. What remains is local. From the perspective of far future observers, if any exist, the universe will appear smaller, calmer, and easier to describe. A handful of galaxies bound together, familiar motions repeating, predictable dynamics. No evidence of vast structures beyond the local environment, not because those structures never existed, but because the pathways that revealed them are gone. This is the quiet ending. It does not feel like catastrophe. It feels like normalization. The sky grows simpler without calling attention to what it has lost. Knowledge stabilizes not because it is complete, but because new information no longer arrives. Understanding plateaus. This challenges a deeply rooted assumption that time naturally brings clarity. In the universe, time often brings silence. The longer you wait, the fewer signals survive the journey. The archive shrinks even as memory accumulates. What you know becomes more refined and less representative. This is not a failure of intelligence or effort. It is a consequence of geometry. The universe expands, and expansion edits relevance. Regions that once mattered stop contributing. Events that once could be known fade into permanent obscurity. The end state is not ignorance. It is partial sufficiency. Observers will know their local universe extremely well. They will understand the physics governing what they can see with exquisite precision. But their conclusions will rest on a narrow foundation. The broader context will be gone. They may not even realize it. Without records, without ancient signals preserved, there will be no indication that the universe was once more connected, more varied, more complex than it appears. The quiet ending does not advertise what it has erased. This creates a strange inversion of confidence. Future knowledge may feel more certain precisely because it is less challenged. Fewer anomalies, fewer distant comparisons, fewer opportunities for surprise. The universe becomes easier to explain because it offers fewer counterexamples. Simplicity arrives not through understanding, but through isolation. For you, living earlier in cosmic history, this carries a different weight. You exist at a time when the universe still reveals its breadth, when distant galaxies still send light, when the cosmic web is still visible, when large-scale structure can still be reconstructed. This is not the beginning of knowledge. It is closer to the middle. Knowing this reframes what it means to understand the universe. Understanding is not a ladder you climb indefinitely. It is a window that opens briefly and then narrows. What you can see depends on when you exist, not just how clever you are. This does not make knowledge futile. It makes it contingent. To know less over time is not to regress. It is to lose access. The difference matters. Regression implies forgetting. The universe does not forget. It continues. Access disappears because the universe no longer allows exchange. Silence replaces dialogue. The quiet ending is not sad in a human sense. There is no suffering implied, no loss felt by the universe itself. It is only unsettling because it contrasts so sharply with human expectation. You expect accumulation. The cosmos delivers subtraction. And yet, within this subtraction lies meaning. Knowing that access is temporary gives the present moment significance. The questions you can ask now may not be askable later. The comparisons you can make may not be possible again. The evidence you can gather exists within a closing window. This does not demand urgency in the sense of panic. It invites attentiveness to what remains visible, attentiveness to how conclusions are framed, attentiveness to preserving context for those who come after, who may inherit a quieter universe and assume it was always that way. The quiet ending also reframes humility, not as a moral posture, but as a rational response to limited access. When you know that your view is partial and temporary, certainty must be proportional. Claims must be bounded by awareness of what cannot be checked. This humility does not weaken science. It strengthens it. Science at its best has always acknowledged limits. What changes here is the permanence of those limits. They are not waiting to be overcome. They are written into the future. To know less over time is to accept that some truths are seasonal. They appear when conditions allow and disappear when they do not. The universe offers moments of visibility, not guarantees. This is the quiet ending, not the end of existence, but the end of shared understanding across vast distances. The universe does not go dark, it goes local. Stars still shine, galaxies still orbit, physics still operates, but the grand conversation across cosmic scales fades into isolated monologues. Each region becomes sufficient unto itself, unaware of how much larger the story once was. You live before that ending fully arrives. That does not make you special in a cosmic sense. It makes you situated. You are here when the universe is still legible at large scales, when memory still reaches far, when distance has not yet completed its work. What you choose to understand, record, and pass on matters not because it preserves everything, but because it preserves context. The universe will continue without witnesses. Knowledge will persist locally, but the breadth of reality will narrow to what can still be seen. The quiet ending does not ask for despair, it asks for clarity. Clarity about where you stand, clarity about what access allows, clarity about the difference between what exists and what can be known. To know less over time is not to fail. It is to live in a universe that does not prioritize understanding, only consistency. Within that universe, meaning does not come from completeness. It comes from awareness that the view you have is temporary, partial, and precious, and that the silence approaching is not an enemy, only the natural conclusion of a cosmos that was never obligated to explain itself in full. The universe does not end with an answer, it ends with quiet.